Students, in this question we are asked that if a transistor having a alpha value 0.98 and the transistor is first used as common base amplifier and then it is used as common emitter amplifier, okay, and the ratio of power gain in two arrangement is what? Okay, so you have to calculate what will be the power in the common base configuration divided by what will be the power in the common emitter configuration, where R out and R in जो ratio है that is same for both the cases. So you just have to know what is the power formula. Okay, so power gain for common base configuration is basically equals to alpha square R out upon R in. This is my relation for common base configuration. The power gain is written as this. So this is one formula that you have to understand. Similarly, the power gain for common emitter configuration is equals to beta square R out by R in. If you recall, so alpha was the current gain in common base configuration and beta was the current gain in common emitter configuration. So we can basically say that current gain square times R out upon R in. Okay, it is the power gain. So power gain is equals to current amplification it is a general formula that we can use, square times R out upon R in. Now it is also given that the ratio of R out and R in is the same in both the cases, so we just have to find out the ratio. Now these are the two things that we have to get in mind. Another thing is that we are given the value of alpha but we are not given the value of beta. Okay, so this alpha value is given to us but the beta value is not given to us. So what is the relation between alpha and beta? So the relation between alpha and beta is such that beta is basically equals to alpha by 1 minus alpha. So if we put the alpha in this equation, we'll get the answer of beta. So alpha is 0.98 in our case, divided by 1 minus 0.98. So we are left with 0.98 divided by 0.02, which is nothing but 49. Now we have the value of beta as well as the value of alpha. So now we can substitute these values to get our answer. So power gain in case of common base divided by power gain in case of common emitter is basically equals to how much? So it will be, so R out by R in will get cancelled out, so we will be left with alpha square upon beta square. So value of alpha is 0.98 times 0.98 divided by 49 times 49. If you do the maths, the ratio will come out to be 1 by 2500. This is the ratio that turns out. So if we check our options, so 1 by 2500, so option A is our correct answer. Okay.